Hello students, this is the video lecture covering section 8.4, Angles of Elevation and Depression. By the end of this lesson, you'll be able to use angles of elevation and depression to solve real-world problems. First, we need some vocabulary. An angle of elevation is the angle formed by a horizontal line and the line of sight to an object above the horizontal line. An angle of depression is the angle formed by a horizontal line and the line of sight to an object below the horizontal line. So here we have a girl looking up at a hang glider. If she was to look straight out along the horizon, she'd be looking along this dotted line. But instead she's looking up, and she's looking up at an angle of 38 degrees. So the angle of elevation from this girl to the hang glider is 38 degrees. Now, if the person in the hang glider was to look straight out, they'd be looking along this dotted line. So in order to look at the young girl, they have to look down, also at an angle of 38 degrees. Since all horizontal lines are parallel, this line of sight acts as a transversal. So we get congruent angles by the alternate interior angles theorem. So the first thing that we want to be able to do is identify angles of elevation and depression in context. So here let's start by taking a look at angle 1. So first off, we should notice that angle 1 is an angle of depression. So here I'm going to call angle 1 the angle of depression. And when we identify these in context, generally we say from one object to the other. So in this case, the object doing the looking is the bird, and it's looking to the person in the hot air balloon. So next let's take a look at angle 2. Angle 2 is certainly an angle of elevation. So here we'll say angle 2 is the angle of elevation. And we need to say where it's going from. So the person doing the looking here, the object doing the looking, is the person in the hot air balloon. And they're looking at the bird. So these are examples of how to identify angles of elevation and depression in context. We want to start by identifying first whether it's an angle of elevation or an angle of depression. In order to do that, you just have to check to see if the line of sight is above or below the dotted line. In this case, the line of sight from the bird to the person in the hot air balloon is below the dotted line for angle 1 and above the dotted line for angle 2. Then, to identify the angles in context, we just need to say who's doing the looking and what are they looking at. So for instance, for angle 4, we would say angle 4 is the angle of elevation from the base of the mountain to the person in the hot air balloon. One of the things that you'll notice is a lot of the questions in this section are word problems. So let's take a look at our first one. Suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the wind turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? So let's start by drawing a picture. So here's our wind farm turbine. Here we are standing 53 feet away from it. We're looking up at the hub at a 56.5 degree angle. If we were to look along the horizon, this is what we would see. We know that our eye height is 5.5 feet from the ground. So 5.5 feet here. Again, we know that we are 53 feet from the wind farm turbine itself. We know that this angle is 56.5 degrees. And we're trying to determine how high the wind farm turbine is from the ground. So let's focus in on the triangle for just a second. We know that this triangle has a 56.5 degree angle. We know that its base is going to be the same as the base along the ground. So we know that this is 53 feet. And so by using this triangle, we can find this distance, and let's call that distance y. Here we have opposite and adjacent. We don't have the hypotenuse for this triangle. So we know that we're going to use the tangent trig function. Tangent of 56.5 degrees is going to equal the opposite side, y, divided by the adjacent side, which is 53. So in this case, we can solve for y, and y is going to equal 53 times the tangent of 56.5 degrees. Now, if we zoom back in on our picture here, this is the distance that we labeled y. So if we copy this distance over to the other side of the figure, we can see that that 5.5 feet gets carried straight over there. So in this case, we can say x is going to equal y plus 5.5, which then is going to equal 53 times the tangent of 56.5 degrees plus 5.5. And if we plug all this into our calculator, we find that the wind farm turbine is approximately 85.5 feet tall from the ground to its hub. Now be very careful. I would imagine some people out there are getting the answer 99.7. If you're getting the answer 99.7, what you're doing is forgetting to close the parentheses around the angle. So make sure that you've closed those parentheses. We want 53 times the tangent of 56.5 degrees, close the parentheses, plus 5.5. And then you should see that it's about 85.5 feet. So let's take a look at another example. We see a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is about 6 feet above the ground, and you're approximately 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So again, let's start by drawing a picture. So here we have our cliff face. We need to add a little rock climber here. So let's add a little rock climber guy. He's making his way up the cliff. We're 1,000 feet away. Let's mark that in our diagram. Okay, we're told that we see him at a 32-degree angle of elevation. So the angle between the line of sight going towards the rock climber and the horizontal is a 32-degree angle. And again, we're told that we have a 6-foot eye height. And we're trying to figure out how far up this guy is on the cliff. So again here, let's start by separating out the mathematical triangle that we're looking at. We're looking at a 32-degree angle. We have a 1,000-foot distance from our eyes to the base of the mountain. And we're trying to determine this height right here. So let's call this x. So in this case, again, we have opposite over adjacent. So we're talking about the tangent of 32 degrees. And that's going to equal x over 1,000. So solving for x, we get that x equals 1,000 times the tangent of 32 degrees. And that's going to give us this value right here. So from here to the horizontal line from the angle of elevation. And that's what we called x. So let's go ahead and solve for x here. X is going to be about 625 feet. But that's not the entire height of the rock climber from the ground. In order to do that, we'd have to take this 6-foot distance and copy it to the other side. So what we really want is 625 plus 6, or about 631 feet. So that guy's pretty far up there. Okay, so let's look at angles of depression. To approach runway 17 of the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3-degree descent starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level, and so to the nearest tenth of a mile, how far from the runway is the airplane at the start of this approach? So again, let's start by drawing a picture. So here we have our airplane trying to get to the airport. It's going to start its descent into the airport, and it's a 3-degree angle of descent. So this angle is 3 degrees. Now, we're told that the airport is 1,007 feet above sea level. So somewhere down here, way down here, we have sea level. Now the distance from there to the airport is 1,007. But the distance from the airplane to sea level is 2,714. So when dealing with angles of depression, we have to build a slightly different triangle. So you can see this is the triangle that we're actually dealing with. We have the 3-degree angle here. We're trying to find how far the airplane is from the runway. So we're trying to find this distance from the airplane to the runway. And so in order to find that distance, we need some other length in this triangle. Well, in this case, we need subtraction because we can see if the total from sea level to the plane is 2,714, and the distance from sea level to the airport is 1,007, then the distance or the height from the airport to the height of the airplane would be the difference of the two, or 1,707 feet. So our reference angle is going to be the 3-degree angle. We have the side opposite of that, and we have the hypotenuse that we're looking for. So in this case, we're going to use sine of 3 degrees, and that's going to equal the opposite side, 1,707, divided by the hypotenuse. So in situations like this previously, we've seen the sine of 3 degrees and the x will switch locations. So we'll get x equals 1,707 divided by the sine of 3 degrees. And to the nearest tenth, that'll give us about 32,616.2. Now there's a small mistake here that I want you guys to be aware of. If we read in the question, we have feet, but our answer is supposed to be in miles. So we need to know how many feet there are in a mile. So we have an answer, but our answer is actually, unfortunately, in incorrect units. We have 32,616.2 feet. So we need to divide this answer by 5,280, the number of feet in 1 mile. And we find that our final answer is approximately 6.2 miles. So one final example here. An airplane pilot sights a life raft at a 26-degree angle depression. The airplane's altitude is 3 kilometers, and we want to know the airplane's horizontal distance from the raft. So here we have our seaplane trying to find that life raft. Got Mr. Kane out there, stuck in the life raft. Help! So it's a 26-degree angle of depression. So from the airplane looking down at the life raft, we know that this is 26 degrees. Now, if we were to drop a line down here, we're trying to find the horizontal distance, d, that the airplane is from the life raft. So this is where it becomes advantageous to actually potentially draw the other triangle. Now, as I stated earlier in the lesson, because all horizontal lines are parallel, this line of sight acts as a transversal. And so this is also 26 degrees. The airplane's altitude, we're told, is 3 kilometers. So now we can use this triangle. Let's go ahead and separate that out from the figure. So here we have the 26-degree angle. We're looking for the horizontal distance d. And we know that this is 3 kilometers above the water. So our reference angle is 26 degrees. We have the opposite side, and we are looking for the adjacent side. So we're going to use tangent. Tangent of 26 degrees is going to equal the opposite, 3, divided by the adjacent, which is d. So again, the tangent of 26 and the d change locations. So we have d equals 3 divided by the tangent of 26 degrees. And so plugging this into our calculator, we find that the plane is a little over 6 kilometers from the raft. The plane is about 6.15 kilometers. So that concludes this video lecture on section 8.4, angles of elevation and depression. Hopefully now you fully understand how to use angles of elevation and depression to solve real-world problems. Thanks for your attention, and I'll see you soon.